So process capability indices have two fundamental purposes. The first one is to have an ongoing performance assessment. So we're looking at this week, this is how our process performed. Next week, how did our process perform, and so on. And the other is we're doing a Lean Six Sigma project, and we want to see what is our baseline. And even though the statistics and formulas are essentially the same, they actually have two completely different functions. So we're going to go with that. Now, the first thing we have to do is we have to talk about assumptions. And we all learn some of the assumptions, but we don't learn all of them. And so we're going to talk about all of the assumptions that go within process capability. Our data should be is probably should be in quotes, independent. Now, what does independent means? That means if I walk out to the line and I grab something, that the next part that I grab should have nothing to do with the previous part. And oftentimes that's violated. So if I'm going out to the line and I grab a part and then I grab a part next to it, those parts may actually be somewhat correlated. But if I wait a couple hours, then I go out and grab a part, it should be very different. That's the idea of independent versus dependent. If there's some relationship between parts, there's dependency. Identically distributed, meaning it all comes from a single population. We'll talk about how that actually works in the real world. Stationary over time. So what that means is if I start looking at the average performance over time, it's going to go up, it's going to go down. But overall, when I plot it out, it looks relatively horizontal or flat. And then finally, we've all been taught that the data needs to be normally distributed. And that's actually not true. It's only true if we want to use the formulas. And so when I worked in the semiconductor industry for 15 years, we had not a single parameter within our industry that was normally distributed. But yet we can do process capability analysis. We just have to work through the issues. So it's not necessary unless you want to just straight out use the formulas. Now, why is this so important? The reason that it's important is we want an accurate statistic. We want to know what has happened in the past, how much of our product has gone to our customers that it truly is in spec. And we also want to infer what's going to happen next week, what's going to happen next month. And do we need to make adjustments to our process to make it better? Now, so far, I've talked a lot in manufacturing terms, but we're going to switch this argument here soon to what happens when we're not manufacturing. So let's talk about this idea of normality. So if you had an academic statistics course somewhere in school, you learned about the normal distribution and you learned about how many standard deviations away you were from the mean, and we called that a z-value. And we learned about z-tables if you're ancient like myself, and if you're new, the numbers pop up. But really what it's about is integrating underneath the area of the curve. So that's really what we want to assess. And that area represents how much is out of spec. Now, because the normal distribution is so well mapped out, that z-value is essentially 3 times our process capability index. So if we know how many standard deviations away we are, then we can figure out what our PPK value is. So that's why normality matters if we want to use this formula. So when we're doing ongoing assessment, I'm going to inspect whether it's weekly, monthly, quarterly, whatever that time frame is. This is what everyone was taught on process capability. And because we were taught that, it relies heavily on getting an accurate statistic. So we need to make sure that our assumptions are met, if at all possible, because we're trying to make decisions based upon this assessment. So with that, one thing that we'll ultimately talk about next week is, do improvements to this process capability index add additional value for the resources required? But for now, we're just assessing how are we doing. So the assumptions in bold and italics should be met. But in reality, our reality is stuff happens. It happens every single day. We have a new lot of material that we're using, and all of a sudden there's a subtle shift in our process average, or we have some sort of unusual event or an outlier or whatever. Stuff happens all the time. And in an ongoing assessment, consistency in how we calculate process capability helps in these period-to-period comparisons. Are we better than we were last period? So if we have outliers and we have a process that's out of control and we just use the same calculation period to period, then if we had that, the process capability index will go down. Now, is it accurate? Perhaps not, but relative to the previous period, we know we're in worse shape. So the biggest challenge that all practitioners face is identifying what is the underlying distribution of the data. And we know in training that we can transform our data. And so we become obsessed in Lean Six Sigma training about transforming the data and listening to engine rooms saying, okay, your best transformation is a log normal or whatever that might be. So I'm going to give you some pragmatic advice. If your data is inherently symmetric, assume normality. On an ongoing assessment, assume normality. So no matter what Anderson-Darling says for that particular test, if there's some little instability, outliers, whatever that might be, if the data is inherently symmetric, you're going to be fine using the normal distribution. If your distribution is skewed, and typically in most processes, and I'll give you an example of one that's not, it's skewed to the right, where the long tail is headed off to the right, attempt to use the log normal. Now, one that is skewed left, an easy one we can all understand, is the weight of a truck on a highway. So federal law says you can't have more than a certain weight in a truck. So companies will attempt to put all sorts of things into that truck to get it up to the maximum weight. So the tail will go in the other direction towards the left. But if you can use log normal, then use that on an ongoing basis, because our computer systems all can calculate the log of numbers. Even if there might be a better distribution for that set of data, if you can consistently use log, that'll put you in better shape. If not, then if your sample size is large enough, use the empirical assessment of the yield, and if it's required, back calculate a process capability. So those are some pieces of advice I would give.